everything. And actually one of the reasons that people hunt deer is because the overpopulation danger. Same thing with turkey, actually. But all right, on topic for anyone tuning in from home because you are not at school today. I totally get it. I wish I was not at school today. So, what? No, I like being with all of you, but I wish all of us were just like at home sleeping and recovering. So, today, hey, let me like do the video thing and then like, so chill for a minute. Today, for those of you playing along at home, we are doing DESMOS. The first activity is called Match My Line. And by the time you would get onto DESMOS, because by the time my video uploads, this will also be there. The second activity will be called Marble Slides. If we do not finish Marble Slides today, we'll probably come back to it Monday. So don't feel like you have to get both of these done if you spend like 45 minutes. But we want to do Match My Line first. So please make sure you do Match My Line first. So until I show like another video, I can keep recording, I guess. So Match My Line starts by saying, plot a line that passes through the given points, right? So on 2, it says adjust the equation so it passes through. Let's do random cards. Laurel, can you tell me what you did with this first, or slide 2, what you did to this to get it to go through the point?
Y equals 0.5x.
Ooh, 0.5x, or how's another way that you can say 0.5? A half. I like using fractions for slope. And as we practice slope, it'll become more and more evident why fractions are nice. You can use decimals. Fractions are just better. So for challenge number 2 that a bunch of us are still looking at. So y equals x, they give us as line 2. Vivian, can you give me an equation that hits one of these points? 2x? Oh, it won't graph it till I fill all of them in, I guess.
No,
Okay.
you press, like, submit.
Ooh, wait. I missed it. 1.5x. Which actually 1.5 is like 3 halves if I want to write it as a fraction. Owen?
Y equals x plus 2.
X. Ooh. Y equals x plus. So instead of messing with the multiplication, Owen's saying, well, y equals x worked here. Hey, friends. Just I want you to see what Owen sees just to make sure that we like don't miss this. Y equals x worked here. So Owen says, well, this is just 2 more up. So leave the y equals x alone and move it 2 up by doing plus 2. Let's check that. And there is another option, right? There is another option. Check my work. It works, except, aw, man, we got to pass through the origin. So y equals x plus 2 would work, but it doesn't pass through the origin. So as you're solving this one, you got to make sure your lines are passing through the origin. I have a trick that I will show you in a moment. But I think we talked last week about rise and run and delta y, delta x. I think we talked about that stuff. My feet feel so much better not in boots. I'm going to leave that. You guys can talk with each other. Like, this can be group work. That is totally encouraged. All right, I got to turn on some other music. Otherwise, I'm just going to keep singing. Yeah. You're welcome.
Angry face and my little swirly thing. That makes me mad.
Hey, you might want that graph paper out from last week. I mean, up to you. But if I was you, I'd get it out to write a couple things on. I want to make sure our friends from home can see what I'm going to write, so let me snap this real quick. Not like Snapchat. Sorry to disappoint. I was snapping from on top of Pete's tower.
No, I was thinking that.
You were?
No.
Yeah, I was on Snapchat with my friends from up there. While I was waiting for groups to come find me. Only 2 groups found me.
Really?
Yeah, we saw
Yeah.
it. Yeah, we found you. We
No.
found you.
Show it, sir.
What? I can't. It's gone now. It's gone.
No, you add
Yeah.
My avatar. I think he's still wearing like Christmas stuff because I do not care. Yeah. So I should probably change it to something spooky, right? Look, maybe if we get all of our Desmos done, then we can decide a new avatar for me.
Bet. That's gonna be so fun. I hate that song.
All right. You want to know the trick?
Yes.
Yeah.
I know.
Slope is rise over run.
Meaning.
Well, so last week, sorry, I'm just trying to, I got too many things going on. Last week we talked about slope being delta y over delta x. Excuse me. But what that means, change in y, change in x, is if I can drop 2 points, which I can always drop 2 points, but if I drop 2 points on a line, the rise compared to the run, we make what is known as the slope triangle. So for this point, if the origin has to be one of our points, to get from here to there, the rise is how much? And the run is how much? So our slope here is 5/3, and that's why fractions are better. Because the decimal of 5/3 is a repeating decimal forever. This is just 5/3, and it's exact. Because if I try to write that as a decimal, it's 1.666 forever. I'll never get to the exact number because it's a forever repeating decimal. This is exact. And if you go down, so what about like this point? Our rise run to get there? Well, if I draw my slope triangle, what's my rise here?
2.5.
What's your rise? -2. Thank you, Cora.
I love you, Cora.
What's the run? Are we going right or left? Right is so this is +3. So that'd be -2/3 x. And I just like to put the negative on. Well, actually, the negative would go with the 2 here. Oh, I guess I could have put that in the one above. Or no, we still need this point. So wait, what about this point from the origin? Triangle. Ooh, wait. Do I have to draw my rise first? Not really. This was getting really busy over here. So I can draw my run first and then do my rise. I just have to make sure when I go to write it, 1/3. Questions right now? So when I look at Desmos, I should see that we're all getting this table filled in.
Bingo.
Bingo, bango, bongo?
What?
I don't know.
Sorry, sir.
Ooh, I got some people on like slide 3 with no lines yet. Oh, wait, maybe you're filling in your table and you just haven't hit check yet.
Yeah.
Ooh. So, I'm going to anonymize, but then if this is you, please don't feel bad. I'm just using this as an example. Oh, crap. They cleared it and they went back. If you had a bunch of decimals typed in that were, like, very close but not quite right, hit check my work again. I want to kind of show it to the class. Maybe I can just look through and find one. So you guys are all famous mathematicians now? All right, so that's fractions. You can. Yeah, if you want to Google your mathematician, you can. Fractions. Now you're all, like, you know, listening to my advice. Ooh! 1 over 1.5. That feels more complicated than it needs to be, but if it works, it works. I feel like this could be easier. Said
Girl.
So we won't really involve y's on the right side. Like, if we have y equals on the left side, we try to not really involve any y's over here because it just kind of gets messy. So be careful. If you are Carl Gauss, you might want to go back and check because we don't really want y's over here.
Sorry, I forgot to put the X. That's why I'm laughing.
If you forget the x, it'll just be horizontal.
Yeah, I see that.
What's going on? So up there, we talked about slope, fraction, rise, or run. So better than a decimal. If you use a fraction, it's more exact. So let's go back to some clean decimals. So for that top piece, our rise compared to our run. What's our rise? From the origin. 5, and then our run is. So what we can type is just 5 over 3. X. So I need you guys to chill like just a little bit. See how that perfectly got it now? So, even though this works, like it looks like it's going through fine, do you really understand what's happening here? Probably not, right? What we do understand is the rise or run thing of like counting the boxes. So let's try to use that. So that one's already done. So this one, to get there, what's our rise, what's our run? Yeah, so the rise was 1, the run was 3, so we use 1/3 there. Hey, I feel like we're like struggling but laughing about it. So we need to be counting the rise compared to the run.
I got that, but no, we just forgot the X. We're just playing with the X. Just to get a straight line.
X, that's rude. Just like cut ties and move on. What? I'm here to teach you more than just math.
Sir, I am not trying to find X, okay? I am not a pirate.
So we like hang on to it, but I'm trying to help people who are a couple slides back from that. So like just keep kind of thinking about it, or talk to Laurel, like you guys can talk together if you want. Alright, so what are we using the calculator for? So you can type the fraction in. So like -6/3, or like we can just leave those fractions as they are. So if you were using -6/3 for this, even though it can be simplified, you could just type that in as the slope. You don't have to simplify it.
Oh.
You can, but you don't have to.
I didn't realize that, sorry.
Yeah, no, you don't need to apologize. It's all good. I'm just letting you know, like, you don't have to. All right, so as most of us are on this slide or past, Mark thinks the equation y equals 4 plus 6x. Oh, Mark put the 4 first and the 6x next. That's not wrong. Hey, Simon, can you get back on task, please? So actually, Simon, you can prove me wrong if you really like know what we're talking about. What does 6x mean in this equation? Yeah, so it's okay that you don't know, but it's not okay to be off task when we're in the middle of an activity, all right? You might want to write this on your graph paper. The equation y equals 4 plus 6x is the same as if we would say 6x plus 4. The 6, or any number that is attached to the x, like we were practicing on the slide before, is what? What is the thing attached to the x?
Slope.
It's the slope. And if you check your graph paper, what we wrote down last week, what's the other thing we were talking about? There's slope, and there is... Check your graph paper. Like, open your binder, check what we wrote on our graph paper last week. Unless I'm crazy and we didn't write it down.
Growth. The intercept.
Yeah! The y-intercept. Guys, so you should have this in your graph paper. This should be in your graph paper. M is our slope. It's our growth. We could now go ahead and write, okay, we also now know from today. Yeah? Sorry, don't know what that is.
Sorry, I don't want you to get too far.
Well, thank you. Rise over run. If you want in your notes, you could also put like, okay, it's the up down over the left right to help you remember. And the other number is the b. So the equation y equals 6x plus 4. 6 would be our slope. But we talked about fractions being better. How can I turn 6 into a fraction?
Divided by 6.
No, what could I divide it by that it still comes out as 6? 1. And the 4... Hey, Amir. Not only are you not doing what I'm asking you to do, but you're making noise and like being distracting. So can you at least not be distracting? I really wish that you were doing what I was asking you to do because this will be useful. But if you're going to choose not to, that's a choice you're going to live with. The y-intercept then is 4, and we don't really need to do anything with that to be able to graph it. So when we go to graph it, we would graph starting at 4 at the y-intercept. So like 1, 2, 3, 4. So we would start at 4. How do I then move to a next point? I look at what the slope tells me to do. Owen, do you know?
Yeah, you go, like, up one, or up the numerator, and then the denominator.
We go up 6 over 1. So we could again, if we wanted to, go up 6 over 1, and from there, we'd be able to graph our line. So when we look at is Mark correct? Mark thinks the equation will match the red graph. Is Mark correct? Answer in Desmos.
No.
No. Mia thinks it's the dotted blue graph. Well, does the dotted blue one start at 4? Ah, crap. It doesn't go up far enough for us to see it. Wait, maybe it's my zoom. Nope, not my zoom. What up? What? Laurel, go down instead. So let's check. Do we have a rise of 6? Well, I can go down, and it would still, like, coming this way, it would still be a rise. Do I have a run of 1? So 1, 6, boom. Rise of 6, run of 1. Even though I wrote the 1 first, rise of 6, run. And guys, you can draw that slope triangle on either side. So you could also draw it over there. If you like it better to draw the rise first, you can draw the rise first. Well, thank you. My brother-in-law got it for me.
From the golf course again?
Yep. Well, this is the same one.
Okay. Are you
So,
friends with your brother-in-law?
are you on challenge 3 yet, and or past it?
I am on challenge 3.
So let's focus on challenge 3.
Wow, sir.
I appreciate the compliments, but I gotta stay focused. Like I myself gotta stay focused. Adjust the equation. Ooh, so it passes through the points. We gotta hit both. Gotta hit both of those blue points. I think we see the y-intercept. I think we can count to figure out the slope. Vivian, are you able to help me adjust this equation? Sorry, what'd you say? You think you got it? All right, what do you think? 4 plus 1.5x. Let's go through and check that. Is the y-intercept at 4? Yes. What is the slope here? Let's draw our triangle. What was our rise? 3. So guys, remember we're counting from point to point. What's our run? 2. So we're going to do y equals, our slope was 3 over 2x plus 4. But what Vivian said was y equals 4 plus 1.5x. Are these different?
No.
I mean, they're different.
There's
They're not
different ways.
different.
Yeah.
They're equivalent. Boom. They are equal. So, sure, like, this is right. Personal preference, this is better. Because if somebody hands you the equation and they say graph this, are you going to count up 1.5 boxes? You'd rather count up 3. I mean, so they're both right. I'm not trying to pick on anyone, but I'm telling you, if you get used to working with the fractions for slope, it's better. It's easier. All right, so let's check what Vivian told us to do. Aha! Got it. Uh-oh. Oh, 4 lines. Okay. Each line should pass through the point on the... Ooh, uh-oh. Should pass through the point on the y-axis. Well, what did we say the point on the y-axis is telling us? Anybody? Claire?
Black dot.
Well, yeah, but what is it telling us? Like, in terms of the equation.
You start with -2.
Yeah, every equation is going to have y equals -2 involved. And you could put the negative in parentheses if you want. And then we'll have whatever the slope is. So I'm actually going to Control-C, Control-V that. And then we got to figure out the slopes of each of them. Got to figure out the slopes of each of them. I will activate marble slides. I have too many windows open. I have too many windows open.
Wait, sir, what point is which? Just go like 1, 2, 3, 4? Or is it 1, 2?
So, like, from this point to the black point, to make that slope triangle, rise would be 1, 2, 3, 4, 5, but negative, right? So
that point's 2.
-5, and the run is 1, 2, 3, 4. So it doesn't matter, like, which one's which, but then you gotta make sure you put your X in there.
I feel caught out.
Boom. Did I activate it? Yeah, oh, and it should be activated now. Oh, yeah. It has to pass through the point on the y-axis. Each line should pass through the point on the y-axis, so that's why we're using the -2. So, well, I'm really concerned that, like, when I'm doing stuff on the board, are you listening or not? So, the y-intercept on the y-axis, right? This is our y-axis. Where we cross that axis is the y-intercept, which is the constant in our equation. It's the number that doesn't have the x. So each of those equations is gonna use the -2. So then, we'll look up here. Then what we gotta figure out is the slope by either imagining or actually drawing it, because I think you can draw on this, from point to point. So, like, for this point, it's still this point, so point to point. So, like, the slope from here to there is -2, 1. So, -2 over 1. Or just -2, right? Because division by 1 doesn't really do anything. So you might want to catch up. We reviewed this stuff. This was one of our equations of the activity. So you might just want to remind yourself of like slope minor sector. And it's up on the left board as well. So go up on those for a second, or I think Simon probably has it written down. So that's really what we did on our graph paper for today. You're good. Just make sure the light is on. You're gonna have to flip the switch. And then to show you marble slides, so maybe like during AO or whatever, you can decide like, oh yeah, I just want to go do that just because I have free time and it's good practice, and then you'll know what you're doing. And so the goal of marble slides is to get the stars. So they give you an equation that we need to modify. I want you guys listening to what marble slides is. So they give me an equation that I need to modify so that when I drop the ball, yeah, normally you don't want to drop the ball, but when I hit like launch, it drops the ball and the line will make it so that I collect all the stars. So, Ahmad, do you have a suggestion for what I could do to this line to maybe try to make it like match up with these stars?
Let's make it like less steeper. Make the slope lower.
Make the slope lower. So like 3? Nope.
No, like a
2?
little bit, no, like a little bit less.
So even a slope of 1 is not less enough. I'm going to do a fraction. So some, like, 1/3? How?
No, 1/2.
Ah! Bum-ba-dum-bum-bum.
It's giving Sonic. we drop it. Yeah.
I mean, I was kind of thinking skee ball, sort of, but yeah, you're right. It's more Sonic because the rings, right? So that is Marble Slides, which is active in Desmos now as well, and it is unfortunate.